folks are working through a couple technical difficulties. Seeing if switching laptops gets the presentation to work again. So yeah, I'm Charles Eckel. I work at Cisco in the DevNet team. And cool, looks like we have slides. Thank you. So I do a lot with open source and with standards. In the DevNet team, the idea is helping developers use platforms and technology that Cisco provides. So in my case, it's where we're contributing a lot to open source, where we're contributing to standards, and where those play a large role in the products and solutions we offer. OpenDaylight is a good example, open source project that has support for networking standards around data modeling, around network management protocols. And because of those, it serves very well as a platform for network programmability. And that's what I'm here to talk to you about today. So just an agenda, very brief, high level, because you probably all know this. What is SDN? But it's kind of to frame the rest of the talk. And then what is OpenDaylight? Again, just a very brief summary. And then talk a bit about network programmability and how it is that OpenDaylight is very well suited for network programmability. Then the idea was to do a demo, which I was worried, might not go off really well, but now it definitely won't go off well. So I'm just going to show you some slides instead and walk you through what I would have done in the demo. But the slides will be available afterwards, and if you're interested in their step-by-step kind of if you wanted to do the same thing yourself, because all this is open source, it's all freely available, and you could do the same setup yourself. And the use case I'm going to show is it working with VPP, and then we'll wrap up with some conclusions. Okay, so what is SDN? Software-defined networking. I guess we're all aware of that. When it first came out, the key principle people thought of, one of them at least, was this separation of the control plane and the data plane, which seemed like a good thing. OpenFlow was a protocol that got defined around that time as a protocol for software-defined networking. Logical separation of the control plane, but then also, because the control plane is separated, instead of having it just spread out over a bunch of different pieces of network equipment, routers and switches, you could centralize all that, right? As soon as you break it apart, the data plane may still be distributed, but you could centralize the control. That was another big thing that came around. And so those are all important aspects of software-defined networking. But I think what's really come about out of software-defined networking that's perhaps more important is programmability. When you make not just the configuration, but the operational data that's in the network, when you make that available to applications through programmable interfaces, you really enable a whole lot of functionality. And that's what I think is where the real power of software-defined networking lies. So with that in mind, if what is it that we then need from an SDN controller? Of course, it needs to have networking capabilities and allow us to control our network, but we really also need it to provide developer-friendly APIs that we can use to access all that information, right? To interact with the network programmatically. But at the same time, we don't want to have to deal with all the complexity of the underlying network, so we want some abstractions there, and we also don't want to care about exactly what networking protocol we're going to use, because it's not like OpenFlow is going to be running everywhere. There's going to be a variety of networking protocols, and we don't want our application to have to behave a lot differently depending on which of those are being used. So with that in mind, then, let's take a look at OpenDaylight and see what it provides in terms of being that kind of platform. So kind of hard to see with the lighting here, but what's in the middle here are all the kind of core and enhanced networking functions that you would typically expect to find in an SDN controller. There's also, but then, so that's kind of table stakes, and OpenDaylight certainly has all that. But then what I think is perhaps really key is above that are the developer-friendly APIs. And I don't know if there's any way to dim the lights a little bit, because it was good before, but I think this is, people, you have a hard time seeing, don't you? Yeah, NetConf, and we'll talk about those later. That provides that access that you need for applications to access the not just the configuration, but also all the real-time data that the network knows about. Then the model-driven abstraction layer, the MD-SAL, that kind of provides that level of abstraction that you need. It also provides a messaging fabric so that the applications can communicate with everything underneath and not have to worry about talking to them individually. They can just interoperate through the MD-SAL. And then very importantly, OpenDaylight has all these different plugins which let you talk to all kinds of different network equipment, not just OpenFlow devices, but Open vSwitch, VPP, physical network equipment from various vendors. Anything that you could possibly have in your network, you can have various plugins that allow OpenDaylight to communicate with it very, very well. So the software architecture of OpenDaylight, it's written in Java. It makes use of the Maven build system, and I think a really key thing is that it's based on the OSGI framework, and we'll look at using Carafe a little bit. That's how you can dynamically load new capabilities into OpenDaylight at runtime. So initially when it comes up, it's just running like the bare infrastructure that it needs to get itself running, and then you add the features in, and you don't have to like take it down to do that. So as your network grows and changes, you could be adding new capabilities. So with that, I'm going to switch gears then to network programmability. And first of all, why do we even care about network programmability? Way back in, I guess, the 90s, there was this simple network management protocol that was defined. It's simple. It manages our network. It should be fantastic, right? The problem was it wasn't. In fact, it wasn't very useful at all for configuring network devices. It maybe helped you get a little bit of visibility into state information and to handle faults, but almost no one was really using it for configuration. So what everyone had to resort to was using the CLI. And the CLI would be like product-specific APIs that are provided. And you could get into the command line and you could type the things you need to know, and you'd learn it over time. You'd love the CLI. But if you think about programmatically using a CLI, it's very brittle. There's not that kind of nice programming interface behind it. You have to do a lot of manipulation of strings and whatnot. It's going to be painful to automate anything when you have only the CLI. So that wasn't good enough. And operators said, hey, the standards that you've provided us for management are just insufficient. We really need something better. And that was this RFC and the IETF that came out that was kind of realizing that and saying, yeah, you're right, we do need something better. What came out of those discussions then was, well, let's take the best practices of what we're doing. We're using SNMP in some ways, and we've learned what we can and can't do with it. We're using the CLI, and we've come up with a lot of cool kind of tools and best practices around the CLI. We know what we need to do operationally. Let's take all of that, and let's think about what type of standards we really need in the networking space to tackle that. And what came out of it was Yang data models and NetConf and RESTConf network management protocols. And now we're going to take a look at those. So Yang, it's a data modeling language for networking. And when I was mentioning before the CLI and it being something you could learn over time and interact with as a person, it's not good for machines. It doesn't have the programmatic type of interfaces that you want. What Yang does is it gives you constraints. So you can define your data model for the configuration and data of your network device very precisely. It provides a lot of the constructs that you would think of when you think of programming, like data structures and reusable types and all these things that make programming in like an object-oriented, say, language very easy and intuitive. You can build on tops of things. That's really what Yang is providing for network data and configuration. This is just an example of a very, the IETF interfaces Yang model, just to give you an idea of what it looks like. It's kind of organizing the information into a well-defined way. In this case, there's a container that has all your interfaces. And then there's a list in there where there's an element for each interface. And then there's leaf nodes that have all the data that's associated with a specific interface. So that's what it looks like in text. Fortunately, there's some other tools that let you work with Yang models. Pyang is a great command line tool. You can validate a Yang model, and you can see it kind of, one option is to have it spit out a tree structure, like what I'm showing there on the right-hand side. Again, all open source. Yang Explorer lets you look at a Yang model. It's like a GUI-based tool and gives you more of a HTML-like interaction experience with it. And then OpenDaylight has some great tools built into it as part of its Yang tools feature. And what that does is lets OpenDaylight interact with Yang models and add support for interacting with them through netconf and restconf. And what OpenDaylight does is actually generates code for all the APIs that are defined by the Yang model. We're going to take a look at that now. The idea would be if I had one or more Yang models that are supported by, say, a network element or that I need for some network function that I'm defining, I can run those through the Yang tools of OpenDaylight, and it generates in real time all the code that I need to interact with those APIs. But then through Maven, you can load those in dynamically as a bundle and add them into OpenDaylight. So now it has the code that you need to support the APIs that are defined by these Yang models. At the same time, as an application developer, you can write your code that says, well, when someone calls this API, what do I want to have happen? And so you can write the kind of real business logic or feature logic behind it and load that in dynamically as well. So in this way, OpenDaylight can grow and learn and add support for new APIs over time, all based on Yang models. I mentioned netconf and restconf. The way this works is Yang is just the data modeling language. It defines what is the data that you're going to send over the wire. But you actually need something to talk to the device. You need a protocol for that. And netconf is one protocol. It runs over SSH primarily. The data, your Yang-based data, is formatted in XML. It provides a lot of nice capabilities for configuration data, things like transactions and the ability to roll back, the ability to validate changes that you're making before you deploy them, the ability to have different data stores, like an operational data store and a configuration data store. It gives you a lot of nice programming capabilities that you need. But it's also pretty heavyweight. And so restconf is another network management protocol that lets you work with Yang models. And that's more of like a web application level type of protocol. It takes all this capability that you have with netconf and maps it onto a REST-based API using REST-based verbs like, get, put, post. And in addition to supporting XML, it supports formatting your Yang-based data as JSON. So if you're used to kind of writing web applications, you're using Python to interact with REST-based APIs, this is going to be a much more intuitive, much more developer-friendly way of interacting with Yang models, is by using REST-based APIs and JSON for the data. The cool thing is it doesn't matter whether you use netconf or restconf or you use both. The actual data is based on Yang anyways, and the data models on the device can be accessed either through netconf or through restconf or both at the same time. It's the exact same data model that you're operating with. It's just two different ways of interacting with that data. So looking at how this works out with OpenDaylight then. So this is kind of oriented the same way as that picture I had before with the MDSAL and all your network functionality here in the core. RESTconf as a high-level API being shown up to applications that sit above OpenDaylight, and then netconf being used to communicate with the network devices underneath it. And in this example, I have it talking to two different VPP nodes, and then an OpenWRT node. And let's just assume that these all support netconf and that there's a set of Yang models that they support. Now, when OpenDaylight communicates with VPP number 1, it would communicate with it via netconf. It would do a hello exchange, establish an SSH connection to it, and it would learn what Yang models VPP supports. It would add that VPP node into its inventory of nodes, and then it would take those Yang models, add them to its cache, and generate all the code in real time that it needs to interact with those Yang models and support the APIs behind them. It would then talk to the next VPP node, and for the sake of argument, let's say it supports the exact same Yang models. So then it would add that node into its inventory, but there's actually no new Yang models to add to its model cache, no new code that it needs to generate. It's already done all that, so it doesn't need to do it again. Now it talks to OpenWRT and adds it into its topology, puts it into its node inventory. And let's say that OpenWRT supports some of the same Yang models, but there's some new ones as well. So then we'd go ahead and add those to our cache, generate the code, and now OpenDaylight's able to interact with and control all 3 of these network devices. And that can all happen at runtime. Okay, great. So now this is where I was going to shift to demo mode, but instead I think we're just going to go through some slides. So the idea here is, what if you wanted to go ahead and install OpenDaylight and get up and running with it and get it working with, what would you do? And you can just download a tar or zip file with the OpenDaylight code. What I'm going to be using in this example is Nitrogen SR1. That's the most recent stable version of OpenDaylight. So you can download that, and then installing it's as simple as this. You just unzip or untar it, depending on which version you pulled down. You CD into the directory that creates, and then you just execute the carafe, .bin /bin/carafe, and that just kicks off OpenDaylight. And this will take, it didn't really take 0 seconds. It probably takes like 5 seconds, and it starts up OpenDaylight. And then this is the interactive command line for operating with OpenDaylight. Now, when OpenDaylight starts up, it starts up with no features enabled on it. So that's part of why it starts up really fast. And then depending on your network, the network elements you want to be able to talk to, the functionality that you need, you add in the features that are important to you. And you do this by, you can do feature list to see all the features that are available, list I to see what's installed, list-R to see what features are required. You can install features this way, one at a time or many, and you can uninstall features. And so what I'm going to show here is for the demo that I was going to do, I want to be able to use the graphical user interface of OpenDaylight, and that's called Deluxe. And I also wanted the ability to interact with the netconf functionality and the restconf functionality. So these are the sets of, these are all the features that I enabled. It's a very small set of the total set of features that OpenDaylight supports, but it's enough for me to basically do something like what I'm showing here to create this type of network. Okay, so I have those features installed. And the way I want to use it is to connect to VPP. Now, VPP, you'll hear more about it later on today. It is a very high-performance open-source software forwarder. In and of itself, it doesn't have support for netconf. So there is a component called Honeycomb, which you see in this picture. And what that does is that adds a netconf interface and a restconf interface to VPP, so you can interact with it that way. Otherwise, there's just this low-level API and a CLI through which you can work with VPP. So what I did was I installed VPP and Honeycomb on a VM, and then I wanted to have it connect to OpenDaylight, as you see here, using netconf. So these were the steps to do it, and in the slides that I'll be posting, there's details on how to do each of these steps. In the demo, I was going to walk through each of these, but I'll just kind of show you how it would have worked. The idea being that we want to be able to connect using netconf directly into VPP. We can do that. We can also use the CLI to talk to VPP. What we're going to do, or what I did, was I set it up to use DBDK by giving it an interface, a physical interface on the VM. And then using Postman, I went through the RESTconf interface of OpenDaylight, and using a put, remember we saw before the RESTconf verbs that we can use, so just doing a put request, I attach VPP to OpenDaylight. And I think I have a screenshot of that we can look at. How many of you are familiar with Postman? It's a real easy way to interact with REST-based APIs like RESTconf. Okay, so because I enabled Deluxe, I have access to this graphical user interface on the bottom right. That's what it essentially looks like. And as I mentioned, here's the request I would make using Postman. It's a put request to add VPP to the topology of OpenDaylight. Oh, and then if you want to grab it later on, the Postman collection I'm using is available here, so you'll have access to all this yourself as well. And this is what it looks like in Postman. Here's my collection of things to interact with VPP and with Honeycomb, and this is just the example of the put request and to add VPP. Now, once I add it, what ends up happening is I have a topology that before was empty. Actually, it contained this. It contained OpenDaylight itself. And the set of all the Yang models, I'm basically seeing all the Yang models that are in the cache. That's what, if I could scroll through this, because if it was a live demo, I could scroll through, you could see all the Yang models, and you would also see the information for the VPP node. And then, using the OpenDaylight UI, you can actually interact with these Yang models as well. What this is called the Yang UI. Each of these is a Yang model, and in this case, I'm going into the network topology Yang model and going down its sort of tree structure that it defines to get to the operational data of the network topology that it has. And I could query here to say, show me a node that is, if you can still see this despite the lights, I'm asking for the VPP1 node. That's the node that I added into my topology. And that would return what you see down here at the bottom, if you're able to see it despite the lighting, is the information for VPP. This is the IP address of my VM with the DBDK interface that I assigned to it. Okay, so that's kind of my abbreviated slide-based demo. And now to wrap up. So the key things I want to leave you with is, first of all, SDN, it started out as OpenFlow. It's much more than that. A great thing that SDN brings to us is network programmability, kind of came out of SDN, and that's a fantastic benefit of it. And OpenDaylight, as an open source platform that supports networking standards such as Yang and netconf and RESTconf, it's set up to be a great platform for writing network-aware applications and interacting programmatically with your network infrastructure, whether it be virtual or physical, whether it be software-based like VPP or some real appliances, routers and switches. Okay, and I guess I don't need to go into this. If I have a little bit of time left, I'll save it for questions.
2 minutes. So one question, I think, probably. Just out of interest, how many people would like to ask a question? 3. I'm going to go with this gentleman.
Sure.
And CC beginning. I was started learning SDN 3 years ago.
Okay.
I started with Coursera course first from University of Texas, I think. and I found that there is no real application which are working, which can be used in production. What situation today? I mean, can you give just a few examples where it works in production in high-load networks, let's say? Because what I found, it was a lot of experiments, but not much real applications. Even HP, who was buzzing a lot, had no working applications.
I'm going to let him answer the question, because I was hoping to get a second one.
So, I mean, maybe just to, I'm going to answer a couple different ways. I don't know if you mean that when you say application, if you mean that people aren't actually deploying OpenDaylight and using it to control their network. I mean, that certainly is happening. I think I see it a little bit more in the service provider space than in, say, enterprise networks. But it is being deployed by large enterprises. It's being used in conjunction with OpenStack for, like, in the OPNFV project for network function virtualization. I mean, that's one way of looking at it. So it certainly is getting deployed. And like with a lot of open source technology, at first there's a lot of hype around it because it seems like it's great, but then it's not ready for prime time. It's very brittle. You probably don't hear as much about OpenDaylight today as you did a few years ago. That's because what's been happening is not super exciting. Not new functionality getting added. Rather, it's getting hardened and easier to deploy. Now, what I'm showing here, this is within the Open Source Dev Center. Yep.
Do you want to sneak in a second question? Because you're running out of time.
Well, I'm just going to show you were talking about applications. Here's a whole set of open source applications that run on top of OpenDaylight, if that's the type of application you're looking for, too. And these are all available through DevNet, the Open Source Dev Center there. And the link's going to be in the slides. A second question, if there's time?
No. Sorry, we ran out of time.
All right. Well, I'll be available.
Okay.
Happy to talk.
Thank you very much, Charles.
Yep.